All right, so we want to talk about the concept of limits. Okay, so let's start with the following problem. Say, let's take f of x, a function given by x squared minus x minus 2 divided by x minus 2. Okay. So if you look at this function, the domain of this function is all real numbers except 0, right? Sorry, except 2, because at 2, the denominator becomes 0 and dividing by 0 has no meaning. So domain of f of x is all real numbers except 2. So I can write it like this. So all real numbers minus 2, or I can also write it as all x such that x is not 2. So this is the domain of this function. So generally so at 2 it's not defined. Generally we basically discard 2 completely and we do not talk about 2 at all, right? However, let's do the following. Let's try to see if your x goes closer to 2, does your function goes closer to some value or not? What do I mean by that? Let's take x closer to 2. So let me take x closer to 2, say for example 1.9, 1.99, 1.999. And I'm wondering what happens to f of x in that case. So your function is not defined at 2. So let's just x go closer and closer to 2 and see what happens to f of x. I don't know how the f of x graph is. We haven't drawn it yet. Okay. Similarly, not only from one side, let's go from the other side as well. Say 2.1, 2.001, 2.0001, for example, and try to find what is the value of f of x. Okay. So I should plug it in my computer, in my calculator, and find these values. Or I can note the following, that my f of x actually is a form, if I factorize it, it is a form x plus 1 times x minus 2 divided by x minus 2. So as long as x is not 2, I can cancel this. So this is same as x plus 1 if x is not 2. Well, if x is 2, then there's nothing. But if x is not 2, then it's x plus 1, right? So this is going to be 1.9 is not 2, right? So it's going to be x plus 1. So it's going to be 2.9, 2.99, 2.999. Similarly, if you look from the other side, we have 3.1, 3.001, because it's x plus 1, right? 3.0001. So what does it looks like? It looks like the following. As x goes to 2, f of x goes to 3. What do you mean by goes? As x goes, or x becomes closer to 2, then f of x becomes closer to 3. This is the concept of limit. So even though the function is not defined at 2, we have limit of this function as x approaches 2 is 3. So let me write down what do I mean by that. So we say we have a definition now. We say limit of f of x as x goes to A is L, I'm trying to generalize the earlier one. Instead of 2, I'm going to say A. Instead of 3, I'm going to say L. Okay. So limit of f of x as x goes to A is L if f of x can be made close to L by taking x close to A. Okay. This is what it means by limit. And if I want to write in a notation, I would write limit. Let me just use a darker. Okay, so I'm going to write limit of f of x as x goes to A equals to L. All right. So in that case, in earlier example, we can say that limit as x goes to 2 of f of x, this was your f of x, right, is equal to what? 3. So this is the concept of limit. So let's investigate this same problem from a graphical perspective. So how do I do this? So let me say x squared minus x minus 2 upon x minus 2 is basically same as x plus 1 if x is not 2, right? Basically, after cancellation and simplification, we saw here, isn't it? So let's draw this function. So x plus 1 is a line, so we need only 2 points to draw it, right, properly. Except at 2, right? So let's say x is 0, then f of x is 0 plus 1, which is 1. When this is 1, it's going to be 1 plus 1, which is 2. So the points are, this corresponds to 2. So 1, 2, 3, and then we have, okay. So when I draw this, this is how the graph will look like. At 2, of course, there's a hole, right, corresponding to 3, right? So let's try to see what happens. So this is 3. So the idea is as x approaches to 2, x is in x-axis, right? Yeah. Then f of x approaches to what? So your function value approaches to, you should see the y value, right? So y value is approaching to what? To 3. And if you approach x from this side, also the y value is approaching to 3. Okay. So this is the concept of limit. Okay. Now, we are approaching, if you go from the right hand, left hand side, it's approaching to 3. So we say limit as x goes to 2 minus. So this is from left. X goes to 2 from left. F of x is 3 in this case. And similarly, limit as x goes to 2 plus f of x is also 3. 2 plus means you're approaching to 2, but from the other side, from the right side. In this case, also the function is approaching to 3. So this is the concept of limit. Okay, so let's digress a little bit more on the left-hand limit and the right-hand limit. So we will look at that from the following problem. Let's look at this example. So take f of x equals to absolute value of x over x. Now, clearly this function is not defined at one point, and which is what? F of x is not defined at 0. And let's talk about, so let's try to understand what is limit of f of x as x goes to 0. Yeah, generally it's better to write the mathematical formulation, right? I mean, same question mathematically. So if I write mathematically, I say limit as x goes to 0 of f of x is equal to what? This is the question we want to answer. Okay, so how do we do this? Let's try to understand first f of x. So I have f of x equal to absolute value of x over x. Now, let's see how does this looks like. So you know the property of absolute value, right? So absolute value of x is, how do you simplify? How do you get rid of this absolute value? You know that absolute value of 2 is 2. Absolute value of 3 is 3. Absolute value of a number which is positive or even 0 is just x. What about absolute value of negative 2? Absolute value of negative 2 is also 2. So if the number is less than 0, it's negative. So for negative number, you have to remove the negative sign. And the way to remove negative sign is to put another negative sign. So absolute value of minus x, if x is greater than or equal to 0, it's x. And if x is less than 0, it's minus x. So how does this simplifies? Then this becomes, if x is greater than 0, it is going to be, absolute value of x is going to be x. So x over x, which is going to be 1. And if x equals to 0, then it's not defined, right? Not defined. And if x is less than 0, then absolute value of x becomes minus x over minus x. And so we get minus x over x, which is minus 1. So how does the function looks like? So let me just rewrite the function. So it's simply 1 if x is greater than 0, minus 1 if x is less than 0, and not defined. Or let me just write short for it as d and e if x is equal to 0. So we have this as a function. Again, our question was limit. What is limit as x goes to 0 of this guy? So let me just draw the function to have a feeling of it. So if x is positive, the function is just 1, right? So this is how the function graph looks like. So 1, negative 1. So this is how the function looks like, okay? It's like 2 lines and separated by. Question is, what is limit as x goes to 0? So how do I answer this question? Let's ask this question in another way. Is my f of x going closer to some fixed value or one value as x goes to 0? So let's answer this question. So what is limit of absolute value of x over x as x goes to 0? So you can see that if x approaches from the right hand side, the limit is basically 1, right? And if you approach from the left hand side, the function is approaching to minus 1. So since the limit depends on which side you go from, so it means that if you're going closer to 0, it's not going closer to fixed value because it depends on which side you're going from to 0. So in this case, we say limit as x goes to 0 of this function does not exist. Okay. So this makes left-hand side and right-hand side clear to us, right? So limit as x goes to 0 plus, that means if we are approaching to function from right, what do you mean by that? Let's just, so in this case, we have, it is 1, limit as x goes to 0 minus f of x, or absolute value of x over is minus 1. Okay, so now the left-hand side and the right-hand side limit should be clear to you. So let me define that explicitly. So what does it mean? Limit as x goes to a plus f of x is L. Let me draw the left hand and the right hand limit for you. So suppose we have a function again at a, we are interested to talk about a. You have a function like this. Suppose this is L, this point is M. In this case, we have limit as x goes to a plus. So if you're approaching to a from this side, your f of x is approaching to L, and we say limit as x goes to a minus f of x is equal to, if you're approaching to x from the left, we have f of x is approaching to what? M. Okay. So from here, we can make the following rule as well, just from the earlier problem, that limit as x goes to a plus f of x, and if it is not equal to limit as x goes to a minus f of x, then what will happen? Limit as x goes to a f of x does not exist. Yeah, I'm just writing what we wrote here in a general term. If you're approaching from left and right, if they're different, then the limit does not exist. Okay, so this is a negative result. Let me write down a positive result associated to it. We say limit as x goes to a f of x is L, if and if only if what happens if you go from left or right. So this is right hand limit and the left hand limit, both are L. Then the limit is L. If the limit is L, then the both left hand and right hand limit are L. Okay, so I'll call this part as right hand limit, and this will be what? Left hand limit. So this is the idea behind the limit. Okay, so left hand limit and the right hand limit, right? So now let's look on another problem. Say let's have f of x. So example, so let's see the following problem. Say f of x equals to x plus 1 if x is less than equal to minus 1, is x squared if x is greater than minus 1, less than equal to 0, right? Less than 0. It is 0 if x is greater than, if x is 0. So I'm defining a piecewise function. Is x squared again if x is bigger than 0 and less than 1, and is x plus 1 if x is greater than equal to 1. Okay, so question is, what is limit as x goes to minus 1 plus limit as x goes to -1 minus what is limit as x goes to -1 of f of x, Then the other problems to ask is what is limit as x goes to 0 plus, limit as x goes to 0 minus, and limit as x goes to 0 of this function is of f of x. Now, although we can do this problem directly, let's draw the graph to see what is happening. Okay, so let's draw the graph. So I'm going to draw the graph of it. Let's label the points. So 1, 2, 3, 1, -1, -2, -3, 1, 2, negative. Okay. Yeah, I'm just taking enough so that I can capture what interesting facts are happening around it. So let's see. So let's draw the first part. So to draw piecewise function, let's look at the first part. So when x is less than equal to -1, it's x plus 1. That's like a line, right? So we need 2 points to draw that piece. So first point, I'll take x equals to -1. Then f of x becomes -1 plus 1, which is what? 0. So at -1, the value is 0. And since it's less than equal to, it's with that point is included. So I'll put a dot. When a point is not included, we'll put a hole like the earlier one. Here at 0, it was not defined. So we put a hole. Yeah. So fill dot means it's defined at that point. Okay. So now let's see. So we get that. Now let's take any other value less than this. So let's take -2. So when x is -2, you get -2 plus 1, which is going to be -1. So at -2, the value is -1. And then I can draw this. So this is the first part of the graph. Okay, so first part is done. From -1 to 0, it's given by x squared. So from -1 is this point to 0, it's given by x squared. And you know how x squared is drawn, right? So we'll draw it. We'll still use -1. -1 becomes -1 square, which is 1. But we'll draw it with a hole because it's not defined by that value, right? So we'll draw that with a hole like this. And up to 0. And also 0 is defined by different rule because it's less than 0. At 0, it's defined by 0. So at 0, the value, sorry, let's change this function, my bad. I want to define by, at 0, I want to define it by 1. Yeah. So at 0, it's defined by 1. So again, dot for the included and hole for excluded, right? So now again, from 0 to 1, it's defined by x squared. So again, like this. And after that, after x greater than equal to 1, it's still x plus 1. So it's a line, 2 points needed. When x is 1, it is 2. And after that, it is defined by a line like that. Okay. So this is the graph of the function. Now let's answer the following question. What is limit as x goes to -1 plus of f of x? So what does it mean? You're approaching, so x goes to -1. So you're going to -1, but the plus on the top indicates you're approaching from right. So if you approach from right, where is the function value going to? It's going closer to what? Closer and closer to 1. So in this case, we say the limit is 1. Similarly, if you get x goes to -1, so you're going to -1, but this sign indicates from left. So if you're approaching to -1 from left, where's the function value going closer and closer to? It's going closer and closer to what? 0. So the right hand, so the left hand limit is 0, right hand limit is 1. Then what can we say about limit as x goes to -1 of f of x? So from both sides, the limit are different. Therefore, the limit does not exist in this case. Now, for the other one, so limit of x goes to 0 plus. So you're going to 0, but from the right-hand side. That's what plus indicates. Your function value is going to what? 0. Similarly, if you're going to 0 from negative, so 0 minus, that means you're going from the left-hand side, your function value is still going to 0. So since the left-hand side limit is 0, right-hand side limit is 0, the limit is 0. Even though the function value is 1, the limit is 0.